All right, we're live. Uh, so let's go ahead and get started. I know we're a little early, but it's more questions, so I wanted to be a little early rather than go over. Funny, by the time we're done doing this online, I'll be pretty good at it. Uh, Identify the conduit threading tool shown. So this, I showed y'all some pictures of it last quiz. This is a ratcheting drophead threader. The official name, the ratcheting threader. All right. Next up is the largest size of rigid metal conduit which can be bent with a mechanical bender is uh, so mechanical bender that's like a Chicago bender. The biggest size rigid would be can be 2-inch aluminum. So there's some nuance in this question. Uh, you can do 2-inch aluminum with the ratcheting Chicago, but 2-inch steel is too tough to bend with the ratcheting Chicago bend. And aluminum is easier to bend, so you can go up to 2-inch. I have seen one, maybe two benders that can do 2-inch that are the Chicago style. But if you go up higher, you're gonna have to get an electric powered or hydraulic powered bender to get those bends. The distance from the back of a 90-degree bend to the bending Mark 1, is the take up. So what they're talking about here is, all right, let me draw some stuff. All right. Is there an easy way to do this? Hey, that's pretty good. All right, so that was pretty good. Let's. Oh well. Almost had it. All right. So you look at, so this would be this to here, your stub length, and then this would be right, this mark right here, bending mark, and then from the end of the stub to the bending mark is your take up. What is the question we were being asked? All right. The distance from the back of a 90 bend to the bending mark is the... Oh, did it backwards. I apologize. So, from your bending mark to the back of the 90, that one is take up. Sorry, it's early for me. I haven't had coffee. So this is your take up right here. And that is essentially, it's the shortest amount of bend that it's the shortest 90 that bender can possibly make. It's going to be kind of bender specific, but they're generally all the same. So on Chicago, it might be, say, 8 inches is your take up. That means any 90 you bend on that Chicago starts at 8 inches. If you want a 10-inch one, you just hang 2 inches of conduit. So if you want a 2-inch one, you just stick 2 inches out past your bending mark. And that creates a 10-inch 90. All right. Blank is the process of determining the characteristics of a particular bender or bending shoe. Charting. Yes. So with Chicago benders or mechanical benders, there's a process called charting, which means you take a scrap piece of conduit, put some marks on it, load it into the bender, and bend to 90 using a level and stuff to make sure you have bent an exact 90. And then you put a couple more marks on the bender and unload, or put a couple more marks on the conduit, take it out of the bender, and then you take measurements off of that. So you put a start mark on your conduit, bend your 90, put an end mark on the conduit. Then you measure that, and that's going to be your pull through for a 90. Without, let me pull up a picture of a Chicago bend. Good picture. No, that's a weird. Stick with this. $1,200. All right, so we have right here. This is where you take all your measurements off of. This spot right here. This is the hook. So you'll load. This will be rotated counterclockwise down, and you'll load your conduit in and hook the end of your conduit with the hook. And then this is where the handle goes. As you ratchet the handle, it bends up to the position it's in right now. As it bends, the conduit slides. The conduit just sticks out past the back. And as you bend, the conduit slides in. That. So a good way to measure your bend, a good quick way, is to put a mark at the front or the back of this little conduit support and measure how much conduit has moved past that support. And that is like a direct way to measure your angle. So if you figure out what a 90-degree bend, like if you determine that 90-degree bend has, and I'm looking for my bending cards right now. If you determine a 90-degree bend has certain pull through, so if you say 9 1/4 is your 90-degree pull through, then you know 45 is going to be half of that. And 60 is going to be 2/3 of that. 30 is going to be 1/3 of that. And so on and so forth. And you can do that by doing a test bend, and now you know a lot of information about that bender, and you're going to be more accurate because not every single bender is built the same. So these, let me get a spot where I can see. These bending cards that we have. I hope that's not mirrored for you guys. But these bending cards that we have don't necessarily apply to all benders. All right, go back to a particular bending shoe is found to have a travel of 9 3/4 inches. What will the travel amount be if you wish to bend a 30? So 9 3/4 divided by 3 is going to be your 30-degree bend. So that's 3 1/4. Because 9 divided by 3 is 3, and 3/4 divided by 3 is 1/4. So 3 1/4 is your 30-degree. And this question has to do with charting a bender. If you want more to do with charting a bender, go through your homework. And they take you step by step through the process, every step of the way. All right, so you have, in this question, you have charted the bender. The take up is 8 inches for 1/2 inch RMC. The travel is 7 1/4, and the gain is 3 1/4. What is the total length of conduit needed to form the bend shown? And the distance between the bending marks is blank. So we shouldn't need this 7 1/4 measurement. That's extra information just meant to confuse you. Need to move this just a little bit. That's better. All right. So we have two 90s with 65 inches of total conduit length. But the issue being we're going to have to subtract gain twice. So 65 is our initial length. Our initial, length. Then you subtract gain. For every 90, because the conduit skips this corner, this 20 inches is measured. Let me open this picture in. Let me open this picture in Paint. I'll be able to draw on it for you. All right, so this 20 inches is measured from here all the way to the end here. And then this 30 is measured from the back of here to the back of here. So there's this corner right here that's being skipped. There's a corner here that's being skipped. Gain represents the amount of conduit that you gain uh, from skipping those corners. So what you would do is 65 is the total, 20, 30, and 15 adds up to 65. Gain is 3 1/4. There's two 90s, so each 90 gains you 3 1/4. So for your overall length, we're going to do minus 3 1/4 minus 3 1/4, or minus 6 1/2. That gives us what? 58 1/2. Let's check our math, our questions. 58 1/2. Okay, there's two answers. Damn it. Okay. Okay, so we're going to have to go a little bit further into it. We have a bending mark here and a bending mark here. The distance between those two bending marks is going to be complex to find. It has to do with setback, I'm sure. Let's see, 58 1/2, 30 minus gain. Gain? It is 26 3/4, but that's not how I would have done it. So I apologize. I don't the rationale behind this. I'll have to come back to this. When charting a bender, a mark is made 10 inches from the conduit support before bending a 90-degree bend. After the bend, okay, 35. I didn't show y'all's answer. When the charting bender, so this one is 10 minus 1.5 is 8.5. So what they're saying is, on that, I'll go back. They made a mark 10 inches away from here. And then as they bent, the conduit moved. And after they got a 90 done, the mark was 1.5 inches away from there. So what was the travel? Well, the travel was 8.5 inches. And that is what they found. On a 3/4 RMC, how far from the end of the conduit will the mark be made to form a 32.5-inch stub up? Okay, you're going to need extra information. But let's use this card that I said was not good in every case. So 3/4 RMC. It's a 90. So it's 7 1/4 is your take up. So 32.5 minus 7 1/4. I don't see that number. But it's 25. Got math? Must have been a 8.5 inch. So this card's no good for this question. I must have stole this one from the homework, and this isn't a good question to have included since it was stolen from the homework, and it had previous questions involved. That's my bad. I'll delete this in revisions. same question, but they had you find in the homework. There is, whenever I was telling you that you start the bender, then they go through and use those questions like this. And this is, I need to delete all this stuff. Yep. Okay. So this one tells you the chart. This is between bending marks if a 30-inch back-to-back bend is made condo use. That back is 7.5, 12.5. From your first bending mark, move going to measures. I believe it's 30 minus 7.5. I apologize. I've forgotten how to do. So the reason that this is so alien to me and probably to you guys is if we had to do a back-to-back bend like this is talking about in the field, we would bend 190, take it out of the bender, and measure again because there's no replacement for redoing your measure, like measuring twice. What this is having you do is this moderately complex method of that requires more information than most of you have usually. Method of getting, and you would take your straight piece of conduit. Oh my god! And put all your marks on that straight piece of conduit. Start with, and then once all your marks are on that conduit, then you would start bending. And if you screwed up anything, you're going to screw up the whole piece of pipe. I prefer to get my marks, like know what my measurements need to be, and then bend my first 90, then get another measurement, put a new mark, and bend my second 90. So that's the actual piece of information you're going to use is make multiple like take your measurements each bend. Hardly anybody does it this way. All right. It is 11 o'clock, which is just in time to end this. I will see you guys in a couple hours. Don't forget to do your test stuff. All right.